Hi, I'm Angus at LabVac. Today up on the bench I have a Leybold D16B. This is the larger model from the D4 and 8 that I've already covered. There are some differences. Mostly it's very similar. There's a few differences that I'll point out as we go. What we're going to do is strip it down completely to all component parts, and then it'll go off and get cleaned, and then it'll all get rebuilt. Stick with it, probably going to be a couple of hours long. Okay, first thing that I want to do, that I do with all pumps, is to get the motor out of the way. Kind of halves the weight straight off. This to me is not an original motor. I haven't seen a D16B with this motor on, and the fact that it's not painted suggests to me that it's been replaced at some point. Doesn't make any difference, but here we go. The big terminal box does make it a little bit tricky to get to the bolts, but we've got 4 bolts to hold the motor on. Very straightforward. There is a Rotex coupling between the motor and the pump. So once these bolts are undone, the motor will just lift straight off the pump like that, and out it comes. That's our rubber element that we're going to replace as part of the service. Also, this rather worn out piece of card here will also get replaced, but for the time being I'm going to take the motor, put it out of the way. I'll test that before it goes back on, but that's our first step. Step 2, I'm going to tip the pump up on end. I have already checked that there's no oil in it, and I'm going to remove this base plate. If you have looked at the D4, D8 video, you may recall that the base plate on there is cast into the adapter and can't be removed. So from my point of view, having a removable base plate is a big improvement in things, just because it was really in the way and it's fixed in place. But there we go. So we'll get that out of the way. That's difference number 1. Needs a good clean. We'll get back to that. And then while we're in this position, there are lots of ways you can go about it. Like I say with all these videos, this is not a complete, total, utter guide. This is the only way to do things. There are many ways to skin a cat. I've said that before in a video and got in trouble for it, so I retract that. Another slight difference that we have on here is we've now got 5 bolts holding the oil box on. But before we take that off, there's a few other things I want to do. So I'm going to remove the inlet and outlet ports. Just unbolt. Again, I do it at this stage. It's not necessary to do. You can tackle these later, but while we've still got a fairly big solid lump of metal that isn't going to walk itself around the bench, I'm just going to crack those off and get them out of the way. They're sealed to the body by O-rings that you are going to want to replace, so they do have to come off at some point. So why not now? So with the bolts out, those will just lever off. And then there's an O-ring which can be pulled out of there now. You can see there's some caked up grease on there. you'll often find, certainly from the factory and also from previous services, that grease being applied. Never entirely sure that that's necessary. What I tend to find is that if you grease seals, the grease attracts dirt and dust, and you end up with it caking up. So far as I can see, the main reason for actually greasing those particular seals is because this is at an angle. When you go to refit this part with its new O-ring in there, if it's dry, it'll fall out. When we come to put it back together, I'll show you how I do that without greasing them and without them falling out. It's not difficult. Underneath the inlet, there is a plate which also needs to be lifted out. I don't want to bend that, it's fairly thin, it's stainless steel. And there's a second O-ring underneath there. So we want to take that out of the way and then just lift that O-ring out. The reason that the plate is there is because the inlet valve piston is offset from the centre there, so it just adapts to that. So this piston with its rubber cap on the top, this pops up when the pump's turned off to seal off the inlet. That cap's going to get replaced as well. You will see me throwing the parts I remove just onto the corner of the bench. I always keep everything. When stripping down the pump, I never throw any of the parts I remove away. Put them all in a pile. You never know. You never know. Occasionally kits, particularly aftermarket kits, there'll be one part missing. And if that one small O-ring or whatever is going to stop you rebuilding the pump, then it might be worth cleaning up the old one and putting it back if it's in reasonable condition. So I tend to hold on to everything. It's also quite useful. The kits will normally cover a number of different pumps, so they're going to have a few components in there that don't apply to the pump you're working on. And so having your pile of parts you removed is quite useful for identifying if there are any bits left over, whether or not you can ignore them safely. So having done that, I'm now going to take the oil box off. You could try to remove this coupling at this stage. The likelihood is that it will be fairly stuck onto the shaft and you haven't got a very good angle to pry at it and lift it out. Leave it in place, the whole thing will drop out and it'll be a lot easier, as you'll see. So 5 bolts holding the oil box on. We can get all of those out of the way. They're pretty long bolts, they're fairly easy to identify. You'll also see, we can't see along the back row there, I throw all the bolts into pots like this. I tend to have, as a minimum, 1 pot for clean bolts, so the ones that are on the outside of the pump, and a second pot for the bolts that we remove inside the pump that are going to be oily, that need to be cleaned. If it's a pump I'm less familiar with, I'll use a lot more pots, and I'll use a pot for the inlet, a pot for the motor, a pot for the oil box, whatever, to keep everything apart. So it's easier to identify putting it back together at the end. So with those bolts removed, we can now lift the pump out from the oil box. It's a heavy pump. Be aware, it is a heavy pump. So just have a first look inside that oil box. That's really quite clean. there is some there's some dirt and debris down at the bottom there, but compared to a lot of the things that I see, I would call that one pretty clean. It's not going to cause me too many issues when it comes to cleaning. So I've balanced that up off camera on a drain pan so that it can get rid of the rest of the oil. And we get our first look at the internals of the pump. If you have looked at the D4B video, you'll see it's very, very similar, just everything's a bit bigger. So I'm going to start by just removing this demister. So you lift those two clips up and flip them over out of the way, and then they'll slide out and can be removed. The alley covering comes off, and then this fibre demister, which is going to be replaced. There's going to be oil underneath this. In this case, there is very little oil underneath it. That can go in my heap. There's usually a lot more oil trapped underneath there, which makes me think this pump's probably been sat for quite a long time since it was last used, and everything's drained away. And then the cartridge, as we call the main pumping section, the cartridge, and this is the adapter plate. These are held on. There are some rods that run through here with 4 nuts on the end. So I'm going to take a 10mm spanner and undo those. It's coming apart quite easily. Those are very loose. Don't feel very tight at all. That's fine. Makes my job a little bit easier at this stage. Pop those out of the way, and then the cartridge will slide off the 4 rods that are exposed there. Straight out like that. So that's our adapter. These rods can now be unthreaded. Got one that's stuck. There's always one that's stuck. Okay, that one doesn't want to move. The threads on here are only at the ends. So there's a large shank in the middle that's plain. So on this occasion, I can just use some grips to hopefully get that to move. There we go. And then that will come out. So that's the 4 rods out, and then this oil box gasket can be lifted off. This is completely shredded, so I'm just going to throw that straight away, because that clearly couldn't be reused even if we needed to. And there's just the little bits of beading that are left behind. So that's all got to be thoroughly cleaned up. And then while we're on the adapter, there are a couple more things that we want to open up from there. So over on this side, there's a plate here, which will nearly always just look like this, 2 screws and a plate. It's actually here so that you can attach external oil filtering, but in all my years I don't really recall ever seeing one that's had that fitted. So it's really just a blanking plate, literally a blanking plate with a gasket underneath it. So if you were using external oil filtering, it would come up through one of these ports, through the filter and back down the other one. In this case and most cases, we're literally just going to clean that, put a new gasket on it and fit it back up. But if you don't, then obviously you run the risk of oil leaks and so on. This lower plate you generally don't need to really bother with. Again, it's there, it's part of the gas ballast circuit on the pump. This is where your gas ballast air will be drawn in. There's a lot of oil in here, so this has clearly been leaking. If you were to use dry nitrogen for your ballast gas or whatever, that's the port you would connect it to. In our case, we just need to get access there to give it a good clean. And then turning it completely upside down, we get to the gas ballast control, and there's a fair sized spring underneath there, so it's worth holding the spring tension down while you undo that. And then with that spring removed, there's a black plastic lever here that needs to be lifted out. Comes out there, it's sealed on an O-ring there, so it's fairly tight in there, but that O-ring needs replacing. And then deep down under there is the seal that on this pump has clearly been leaking, the seal for the gas ballast. So we've got to get that out. It's tricky to get access to. If you don't have anything else, then you can get down there with a screwdriver and pry it out. It's going to take you a little while. The way I do it, if you have the tools available, this is a split collet puller, generally used for bearings. As you tighten this up, you see it opens up the splits in the collet. Now that should fit straight down in there, and then as I open it up, it'll expand behind the seal and allow me to get hold of it. And then I've got a slide hammer to go on the top. Fingers crossed. Didn't work. It slipped out of the seal. It doesn't look like a standard seal in there. Let's investigate further. I'm going to put some tools on there and get a tighter grip on it. This is all part of the fun. Right, let's go again. There we go. Let's pull the seal out. Let's have a little look at that. Well, it is. It is the Leybold seal. It looks rock hard. That should be nice and soft. Okay, so we've got evidence of why that pump was leaking oil. So there we go. That's everything that we need to remove from the adapter. So that's all going to get a thorough clean. Get rid of some of the mess I've made. We can move into the heart of the pump. So we can now get a proper look at the coupling. Like I said, while it was in the adapter, it would have been very difficult to pry this up should we need to. So down in the middle here we need a 3mm Allen key. To undo that centre bolt, there we go. So this bolt holds the coupling in place fairly obviously, but it also compresses the seal. That's crucial to stopping any oil leaks. So that's the part there, and then came straight off without any prying at all. They're often quite stuck, so you can put levers underneath here, get them right in underneath and lift it if you need to. But that one's come off nice and easily. And then there's a key here that we need to remove. A couple of ways to do this. If you can get hold of the top of it and knock it clear, that's the quickest way, which doesn't seem to want to work. If that doesn't work, then I use these. They're essentially a face plier, but there's no serrations on there, so grip the key like that. Just work it out of the slot. There we go. It's tight in there. And I can get my little screwdriver in behind and lever it the rest of the way out. He says, there we go. So it's just a regular key. I'm going to put all of that lot together in a pot so that I can still find it come the end. So the next thing to do is to remove this plate, which is the outer housing for the oil pump and also holds the outer shaft seal. So it's a 3mm Allen key again for these. And you'll notice as I do this that alongside these two screws we have two more holes in this plate, and those two are threaded. So they're intended as jacking points for the plate, which again will be fairly well stuck down. So these two screws I'm just taking out of their normal locations and then threading into those holes, and then as I tighten those down they'll push against the body of the pump and lift that plate away. So even if it is fairly well stuck down, you can see it makes it pretty easy to force it loose and then lift the plate off. Okay, so it's going to be stuck on that O-ring that seals it underneath, and just take those screws out, ready to reuse. So the outer shaft seal, as I say, is also housed in this block. So to get that out, again, there are lots of ways to do most of these jobs. In the first instant, I'm going to take out this screwdriver. It's very old and has no sharp edges on it. It's been ground away. I'm going to slide that underneath the seal and then push it all the way in under the seal and give it a twist, and hopefully that'll be enough to pop the seal out of the housing. Might have to work it all the way around just to break it away. There are special tools you can use for this. Again, the split collets are one option, but generally speaking, the smaller the housing that you're removing the seal from, the more difficult it is to get any pull from the split collets. So this will generally do the trick, but what we're seeing with this pump is it's obviously been run well beyond the service interval and everything's really hardened off and stuck in place. But there we go, that's broken it loose. And that seal comes out of the way. You obviously want to be careful not to put too much damage into the metal parts that you're reusing. There are some light scratches in there. I'm not going to worry about that because when the new seal goes in, that's actually not going to interfere with any of the sealing surfaces. So that's that part. There's a gasket here, which again just gets lifted off. And once again, it's been in there too long, and so it's all stuck and left all its beading behind. So to remove that beading, a little bit of solvent, and then the quickest way I've found, I'm in the UK here, we call these Stanley knife blades. There'll be something similar available wherever you are, and then just holding it very flat, just slide it in underneath and it will lift everything up. You've got to be careful, obviously, not to scratch these surfaces, because these are the sealing surfaces for the new gasket when it goes back together. But as you can see, you can work around fairly easily like that, and it'll take all of that beading off. Give me a clean surface. So now we can see we have that O-ring that needs to come out. Just using a pick to gently loosen that out of its position. Pull that out, that'll get replaced. And then we have the two cogs that form the oil pump. These DB pumps all use this cog system as the oil pump. As it rotates, the position of the cogs open and close the volume that the oil can occupy, so it sucks oil up through here and forces it out through the top of the mechanism. They're going to be very difficult to remove at this stage. Don't try and pry them and pull them, because if these parts do get any nicks or scratches in, that will cause a problem. It'll cause them to either not perform properly, or in the worst case, if you've got nicks in there, it can actually lock up and cause problems. They'll come off easily enough later on. Don't try and remove them at this stage. I'll just leave them where they are. So, turn it back over. Let's do the easy bits first. So, one bolt here will remove both of the valves. So the final exhaust valve and the interstage valve are formed from a single plate. So that's our backing plate that will go back in, and that's the actual valve plate itself. which should be replaced. So that can go in the heap there. That's it for the top side for the moment. I'm going to go over onto the end where the oil overpressure plate can be removed. And again, that plate should be in your kit, but the screws won't be, so you need to retain those. There's one other part on here just to notice, which is down here. There's a control orifice. They're usually around a 0.8, 0.9 millimeter size. There's no need to remove that. We do need to make sure that it's clear through, but we can do that easily during the cleaning process by just spraying some solvent into it and making sure it comes out the other side. Maybe a bit of compressed air, a couple of goes at that, make sure it's clear through, but you don't need to remove it from the end plate in order to do that. So leave it in place. It's fairly fragile, better left alone if you can. And the final one of the external bits of this cartridge is up here now. This one is fairly caked. I'm just going to give that a bit of a clean, get rid of some of that, because underneath here we need to remove a spring clip, and then under there is a piston and a couple of seals that we need to replace as we go. So okay, now you can actually see what's supposed to be there. We need some circlip pliers into the holes in the ears. This is going to spring across the room if you're unlucky, so just be careful as that comes out. So we've got a circlip. It's a custom circlip for these pumps. I've never seen them in anything else, so you need to hang on to that. If it does ping across the room, chase it. This top plate we need to reuse. Underneath that is a gasket which will be replaced, which again is firmly stuck in place. So I'm going to carefully encourage that to come off. It's just going to crack into a million pieces, which is fine. We're replacing it anyway. There we go. Then they'll get a new one of those. That's the plate. Next comes the piston, which is in lovely clean condition. No problem there. And there is a spring that the whole thing sits on. And then down in the bottom of there is another small seal that we need to remove. This one I'm going to do just with the pick. I can see it from here. It's probably way too small for you to see from the camera position, but you can just tease that out fairly easily and lift it up, and there's that seal, which was installed upside down. But that again is going to be a part that's in the kit. More detail on that when we come to put it back together again. The eagle-eyed among you may have noticed a little silver disc there that has appeared. There it is. Now that sits in this recess here. And that's where it was, and it's just fallen out when I've been working on the pump. All that does is it closes off the end of here. There are dowels in here that we're just about to remove, and that blanking plate covers that dowel. Only that one, none of the others are covered. I can't give you an explanation for why that one needs to be covered. I've seen plenty of these pumps that don't have that in place, and they seem to work fine, but that's where that's come from. So now we need to separate the various sections. So as I've just alluded to, these are doweled together. A couple of ways of going about this. The most common way is to take a large screwdriver such as this one, place it into the sides of the sections somewhere solid and give it a hefty whack with a hammer on the end to knock the sections apart. That'd be the most common way. Proper way to do it, which I'll show you first before almost certainly resorting to whacking it with a hammer anyway, is to use a dowel remover or extractor slide hammer. So our dowels sit here and they are threaded. So if I clear out the end of them a little bit, we can screw a bolt down into there. It'd be helpful if I pick the right size bolt. M5 for those of you who are keeping track. We need a 4mm Allen key. And then this device allows me to screw right down into the dowel. Then attach a slide hammer to that. And then put the whole thing down at an angle. Hopefully you can still see that. Yeah. And then without catching my knuckles on the bench, just pull the dowel out like that. And then remove it. A slightly time-consuming process to do them all like this. And sometimes they are very, very stuck. Hence the resorting to knocking it apart, which often happens. This particular dowel now is entirely stuck onto the thread there. There we go. So there's actually 6 of these in the pump. I'm going to do the next one in the same way just to show you how that comes apart, and then we'll decide after that whether to go through the whole process properly. These are coming out, that first one came out pretty easily, to be fair. Sometimes you really need a lot of force. That's tapping out. Lovely. So with the dowels removed, this first section is now loose. You can see the swivel. There's still oil inside the pump, and the oil has a surface tension, which is all that's holding it now. So all we've got to do, he says, is overcome that surface tension. That end plate will come off. There we go. So as you see, there's a lot of oil still inside the pump. Yeah, that's caught on camera. And that's exerting enough tension to hold the parts together. So inside here we've got our rotor and vanes. So they're the vanes. Depending on the kit that you've bought and how bad your pump is, you may or may not be replacing those. I don't think we are in this one. And then I'll just pull that apart. Again, it's just the surface tension of the oil that was holding the rotor into the end plate there. So that can come out. And then if I hold that up, hopefully just there where my finger is, bring it into camera range, is that orifice that I mentioned. So I'm not going to show all of the cleaning on here, but what we are going to want to do as part of the cleaning process, just spray some solvent through there, make sure it's coming out the other side, follow it up with some compressed air, do that a few times just to make sure that's completely clear, but it does mean that we don't actually need to remove that screw. Like I say, the way they're made, they are quite a delicate piece, so they're quite easily damaged if you do remove them. There's also up here another one which we'll tackle in the same way. And I want to get rid of some of this oil, so I've got down here on the floor a big bucket for oil. And I drain that off there. When you are doing things like that, obviously be careful there's nothing loose, because if you drop something out of there and it disappears into the oil can, then you've got a few extra hours added onto your day. Okay, next stage. We should be able to repeat the same process to get hold of the next two dowels, which are running through here. Now, I'll give it a go. It's not always possible. A couple of things can happen. One is that the dowels have been driven in further than your tool will reach, which is the case here. The other thing that can happen is these dowels are only drilled and tapped one end. So we've got a thread on this side, plain end on that side. If the previous guy put them in the wrong way round, or the other way round, shall we say, then it doesn't matter. You're not going to be able to get those. So let's go to technique number 2 and illustrate that. So we need to remove, we've got two sections here that we're looking at. The first is the stator and then the centre bearing plate. When you do this, you want to make sure that you go deep in. If you're on the edge, these are pretty robust, but if you are on the edge, it is cast, so you can chip it. So give it a little tap like that, and you'll see that's starting to open up. Make sure you go evenly at both sides, so that you don't twist on the dowels. And then once you've got a bit of a gap opening up there, I would go in with a couple of screwdrivers, place them between the stages, right where the dowels are, one above, one below, and then gently push it off from there. If it does stick like this one is, sticks on one side, then just apply both levers on the same side. You do want to be careful, obviously, there. You don't want to scratch any of these surfaces. So blunt screwdrivers are a good way of going about it. If it's really stuck in place, don't be tempted to lever too hard, because you will leave marks. So that's the LabVac stator, and incorporated into there is a spring and pad which forms the gas ballast non-return valve. So that needs to come out. That will get replaced from the kit, and that's our stator. You can do a first inspection. That one looks pretty nice. Take that out of the way. Now we're back to the option. Okay, so we've now got access to those two dowels, so we can pull those with the tool. The obvious advantage to doing it with the tool is that you're not running the risk of scratching up the metal surfaces, because these are coming out fairly easily. Hopefully tap that out. You'll see those centre ones are quite a bit longer than the first two that we took out. That's because they run through the 3 sections. There we go. Dowels out. Next section should lift off. So that's our centre bearing plate. No additional parts on there. Looks to be in good condition. You can see there's very slight wear where the rotors sit against it. That's perfectly normal. Nothing to be concerned about. There are little oil ways through here, so down through here and also over here. And again, they need to be thoroughly cleaned. And now we can remove the HiVac rotor out of here. Now, the HiVac rotor has still got those cogs on the back, the oil pump, but they're going to come away fairly easily. There's nothing else holding it there now. So I'm going to give it a few taps on that end, drive it through, and everything will fall off from this end. So looking back here, we've got the outer of the two oil pump cogs has fallen off of its own accord. The inner one is now loose, but it won't come off because we've still got the rotor ring that the shaft seal sits on, which has come so far, but not all the way. There we go. Let's pull that off. Now, I said I'd point out the differences between the D4B and the D16. On the D4B, there is an O-ring here and a washer, and then the coupling sits on top of that. And as you tighten the coupling up, it compresses the O-ring and forms the seal to stop oil coming out underneath the rotor ring. You don't have that on the 16 and 25. If you start looking for it, I had this question recently. They watched the D4 video, then worked on a D16 and said, this part's missing. What's the problem with my pump? It's not supposed to be there. It's a slightly different arrangement on here. The O-ring, let me just remove that cog. We'll come back to that in a moment. The O-ring on the 16 and 25 has been moved and is now sitting on the shaft, which I think you can see there. The O-ring is there and it's in a groove on the shaft itself. So when that rotor ring goes on, it sits over that O-ring and obviously compresses it against the rotor ring. So it doesn't need the external O-ring that you see on the D4. So that's another key difference between the two. And then the final thing to look at here, because this came off early, this is actually keyed onto the shaft. So there is a very small key just there on the rotor shaft, and that will come out through the body of the pump, no problem. Okay, so let me just take those vanes out. You can see the key there. They're normally pretty well stuck in there and they normally won't fall out. However, depending on how you set about cleaning this, you put it in a bath of solvent and then take it out an hour later and you'll find that's disappeared. So if it's at all loose, or if you're going to leave the part sitting around for a while, or if you're going to use anything other than just cleaning it with a wipe, it's worth removing that so it doesn't get lost, because you are not going to find a replacement for it anywhere local to you. So again, you would use those grips. Just get hold of it and lift it out like that. If it's stuck in there, you may need to just put a bit of solvent on it first, and then once you've got that removed, put it away somewhere carefully, and then play let's try and find the part later. So that O-ring needs to come out of there. Obviously we get a new one, and that's where the missing O-ring is on the 16 and 25. So we're all the way down now to the last two parts here that need to come apart. Again, we've got dowels through here, and I can see the threads in them are at this end. So I'm going to go back to my tool, hope that it will reach. Barely. I'm not going to get enough on that. I'm not going to get enough on that to take it that way. I'm going to see if I can knock it free. I've got a lot to grab hold of now, but hopefully with a little bit of persuasion, I can remove this. It is just a case then of working your way round, being mindful to put whatever tools you're using into a position where if they do leave a mark, it's not going to be critical to getting the pump resealed. Nearly got enough of a gap. Get in there now. Just get in there with those. Persuade those apart. Thought I had it there, but not quite. So without being too brutal, there it is, all apart. Again, nothing else to remove from the LabVac stator. Those dowels do need to come out. Once you've got to this point though, you can either go with the tool or you can tap them out. If you're going to tap them out, find the blind end rather than tapping into the thread and risk damaging that. So just put a drift against the end. These are properly stuck. Okay, not going to waste too much time on that now. What I will do with that to get those to free off is I'll put some solvent in and let it sit for 10 minutes, and that will hopefully release those. But I can obviously get the tool onto those and take them out that way. The final thing to remove on here is the inner shaft seal, which is sitting there. I'm going to do exactly the same as I did with the outer shaft seal. Take my blunt screwdriver, carefully slide it in all the way underneath that seal. Keep pushing until it breaks the seal away from the metal, and then try to just lift it out. As I say, it's not the only way to do this. You will possibly have other techniques or other tools that you prefer to use. This is just so you can see the inside of the pump. It's no definitive guide to how to tackle things. This one's properly stuck in there. Again, a little bit of solvent might just help to free it off. The other approach you can take, not necessarily recommending this, but I'm going to show you anyway, is you can take normally a smaller screwdriver, a very small one here, and put it in. The tight seal that's been formed here is on the outer ring of this seal, and that's what needs to be broken away. So you can go into there, give that a tap, and that will break away. Now, the reason that I don't go straight to that technique, which is the one that's most likely to guarantee results, you greatly increase the risk of actually leaving damaging marks. So I'm going to keep working at it this way. Because I'm less likely to cause any grief down the line if I can get it to come with that kind of persuasion. The other thing we can do is, still with it in that position, just give that a tap. To force it underneath. It's well and truly stuck. Final option, if it really won't shift, of course, is put it in a bath of solvent and leave it. If you give it half an hour in a bath, particularly anything that's warm, will certainly help to free that up and get rid of it. But I'm going to go one more time while the camera's rolling. I'm going to try. So I've just driven that with a fair bit of force down into there. And then again, I want to twist. I don't want to lever, because if I lever across, although it will work, I'm certain to leave a mark in that metal there, possibly quite a deep mark. So I'm twisting instead. Get a good grip. Give it a twist. You can see that seal now has broken away. It's going to totally destroy and deform the seal. That doesn't matter. It's being replaced anyway. What we don't want to do, obviously, is deform the metalwork. So back underneath it, having got it just to break away like that. And try and work that round. It's still not moving at all. So back in there, twist. See, I know this is going to work, but I also know this is the most likely way to leave a mark. Okay, so that's pretty well deformed now, so I should be able to get that out. There we go. So that's the shaft seal removed. In terms of marks left, let's have a look. Definitely left some marking here. I can polish that out with a bit of wet and dry, but actually that surface, not so critical. The new seal will sit in there and will still grip fine against that. What I've managed to not do is put any kind of dents into that lip. That's where the rotor is going to sit, so my rotor is going to be backed up into there. What I don't want is any sharp edges on here that are going to stick against the rotor and stop it turning. So I'll give that a very light wet and dry round there just to make sure everything's smooth before the pump goes back together. So that's the strip down complete. That's all the parts that we need to remove have been removed. It all goes away now. There'll be a couple of hours of cleaning, polishing and swearing, and then I'll bring it all back clean and show you how to put it back together again. Alright, welcome back on what has been a very short break for you, during which the elves have been in and cleaned everything for me. All the parts are sorted, ready to go back together. So I want to start with the oil box because I realised during cleaning that I hadn't actually shown you the strip down of the oil box. There's very little that you missed, to be honest. We have 3 of these plugs, 2 that sit up at the top here for filling with oil, 1 that sits down here for draining the oil. All 3 plugs are identical. What I tend to do is clean them all up, pick the best one and put it in as the drain, because that's going to actually be in the oil that's in the pump, where the 2 at the top are clear of the oil. So if you've got one that's a little bit corroded or worn, put it in up here. You're only ever going to fill through one of those. Why there are 2, who knows. And then the other thing that's on here is the sight glass. Sight glass is really important, and it's important to take it out and clean it, because that's how you tell the condition of the oil in the pump. So that will be sitting there and has 4 screws, as you'll see when I put it back in a moment. Undo the 4 screws, it's usually quite tight, give it a wriggle and lift that part out, that sort of housing. And then underneath that you will have a paper gasket sitting on top of the sight glass. So the paper gasket comes out, that's the new one, I've thrown the old one away. And then again you can wriggle the glass free. The kit I've got comes with a new glass, but obviously it's reasonably easy to clean that if you need to put it back in. And underneath that, sitting around here, will be this large O-ring that stops the oil coming out. So hoik that out, again that's getting replaced, and that would have been the strip down had I bothered to show it to you. So in terms of the rebuild, I've got it here, we might as well do that. So I've got my kit, I've got a whole load of gaskets including that paper one that I'm just about to use. Pop those over to the side, and we'll look at each thing as we go through. There's my new sight glass, and then in the bag of O-rings, the largest one there is for installing the new sight glass. So obviously it starts out as an O-ring, so just squeeze it into place around there. And the glass sits on top of that with the paper on top, and the paper is there just to give you something between the aluminium housing and the glass to stop it sticking, cracking, whatever. Sits in there, and then the 4 screws that I took out can go straight back in. Now that big O-ring, I'll say it now, I'll probably say it several times during the rebuild. The O-rings that we're putting in are doing the sealing. Okay, so when we tighten screws down, we don't need to go heavy on them. They just need to pinch the components against the O-rings and let the O-rings do the seal. So we're not putting a lot of force onto any of this. Most manufacturers do not give torque specs for any of these. I certainly don't work to torque specs. Part of what you gain by experience is knowing when something's tight, but you can see from the way I'm using the Allen key, I'm literally just nipping these screws down, and that big old O-ring under there is what's making the seal. If you really want to, you can go lightly that way, but this is a 3mm Allen key, so you ain't going to get a lot of torque out of it, even if you try. And what you should be aware of is that in most cases, you're putting stainless steel screws into aluminium. So if you over tighten things, what's going to happen is you're going to strip the aluminium thread out of the very large and expensive part, while the screw that's cheap and throwawayable is going to come out just fine. So you do not want to over tighten things. So each of these plugs receives a little flat washer. These are usually green, but they don't have to be. Pretty much all of the O-rings that we use with vacuum pumps are Viton, which is a brand name. The generic chemical name is FKM, and FKM is a highly resistant elastomer, but it can be made in a number of different colours. Certain manufacturers have their favourites in terms of colour, so you'll often see green, you'll also see black, you'll also see brown. They're all the same from a chemical point of view, from a shore hardness point of view, etc. They're all going to be the same, regardless of the colour. So all these plugs can be nipped into place. We'll go around and tighten off any ports later on. The only one obviously that really needs to be snugged in quite tight is the drain port. So that's rebuilt essentially. I'll come back to the exhaust flange when the pump's together. So I'll get that out of the way and we can have a quick look at what's contained in my kit. Now, I mentioned that we've got the gasket, so we've got the gasket that sits between the cartridge and the adapter. We've got the smaller gaskets for the side port that we looked at, and for the sprung plunger. That's the main oil box gasket, and we have one for the motor, which is called a ducting plate. And then, having got those out of the way, we get to this fibrous demister, which will go in towards the end. A series of O-rings, which we'll detail as we go through. The various small formed seals that I took out. The pad for the inlet valve, pair of shaft seals, a new rubber for the coupling between the motor and the pump, and then here are the first ones. I did say the kit covers, in this instance, two different sizes of pump. So this is the part we took out, this is the valve plate that we took out. We also have this one in the kit. This is for a 25, which is the next size up in pump. We're not going to use that. So there's your first part, and if you've still got your pile of bits that you took out, you can quickly do a comparison and know, yeah, no, that's not for me. Likewise in the springs, we have two springs for the piston. Personally, I cannot tell them apart. So use whichever one. It's never made a difference to me. We've got a new rotor ring for the shaft, so we don't have to worry about the wear that we saw on the old one that came out. It's actually not that bad. It would be reusable, but we don't need to. We've got a new one. So they're the bits and pieces that we're working with, and I will show you each one obviously as we put them together. Let's get that out of the way. So as I said with the strip down, there is no absolute correct sequence to work through. You can basically put things in, to an extent at least, put things in the order that suits you. There are certain areas, obviously, where we have to do things in sequence, but for the most part, we're reasonably flexible with these things. So I'm going to start by just putting the adapter together, get rid of a few of the parts from the kit. So that side port for the external oil gets a new gasket. That one fits lovely. Often find with these that they don't quite fit, and you maybe have to trim a little bit of the card off, being very careful obviously not to nick the beads that are on there, but you can trim it if you need to. And now I have lost the plate. There we go. So this again is cleaned up, ready to go back on. There's not a lot else to say about that part, to be honest. What I didn't do, of course, was neatly lay out all the screws. So sue me. So 4mm Allen key, put those in. Snug that in, and go a little bit tighter with these, because we want to make sure that gasket is actually sealed down, but again, we're not going crazy. That's in place. I cleaned out this area. As you saw when this plate came off, there's actually nothing under there that we needed to address. So that plate can go straight back in. Sometimes helpful to just aid access to the seal that comes out from underneath, but I tend not to put it back in at that point. So the gas ballast underneath, this is where our plunger, this black piston, was fitted, and this is the new seal that goes up underneath that. And if I dig through the old parts, you can see that's what came out. It is the same part, but it's considerably older, and this one has some give in it, whereas the old one was completely dried out and solid. So we can put that into place. It drops down into there, into its own little well at the bottom, but it does need to be driven in. So hopefully you can see I've just sort of nudged that around with a finger to get it to line up fairly straight. And then this will be the first thing that needs to be installed with a seal driver. So if you haven't seen it before, this is the type of set that I use to drive all the seals home. I don't use any power tools, I don't use a press for doing things like this. Basically you select whichever of these drivers best fits the part that you're working with. You attach the right size handle to it, and then you drive it with a mallet. So it's down inside there. I'm going to lower that down on top of it. I want to just wriggle it round, give it a bit of a push by hand, just to try and make sure it goes in straight. If any of these seals or bearings or whatever you're installing goes off centre, it can be very difficult to get it straight again. So just want to get that sitting true, and then give it a stern clout to drive it home. And that looks good to me. I would usually do this off on another bench, which is a little bit more rigid and hasn't got all these loose components that are going to fly off. So I'll just give that a firmer whack there, and somewhere up in there. I don't know whether you can even see it at this point, but it's deep down in there. Deep down in there. So back to my kit, and I've got an O-ring which is going to go on here. I'll work that down until it fits into its groove there. Just tucks in, make sure that's all good. And then, to give that the best possible chance of staying soft and supple for a reasonable period of time, I'm going to put a bit of vacuum grease just around that seal. I did mention earlier I try to avoid greasing things where it's not necessary, just because the grease will attract dirt and dust and trap it. You can end up with a worse seal than you would have, but this is actually acting as a lubricant here to allow this piston to slide up and down inside that chamber. So there's some grease on there. That then pushes up against the seal. Only fits in one way, which is handy. And then we've got a new spring that sits in the well in the middle. And then that's held in place with the screw that we took out. 4mm Allen key again, get that lined up, and then you can hopefully see it. It starts off at a wild angle, so you just want to push that down by hand. Just work the screw down, tighten it off. Again, only got to be snug. And that's everything back on the adapter other than that inlet valve, which I will take care of later. So that can move out of the way for just a moment. Next thing I'm going to do is assemble the cartridge. The cartridge is the sort of collective term for all of the major components that make the pump work, the actual pumping chambers doing the job. If you've got a number of different pumps, different makes, different models, most modern pumps, you can build the cartridges I'm about to illustrate. Some of them do have to actually be built in a completely different way. If they have a through shaft or something like that, then you'll actually have to build in a separate way. So not everything applies to everything, but a lot of the general rules do. So one of the things I haven't talked about is the cleaning. There's a separate video on the channel about cleaning the pumps. I never include it in the strip down and rebuild. Firstly, because it's going to take 1, 2, 3, 4, 5 hours to do the cleaning. It can be a very long and laborious process depending on the condition of the pump. And these videos are too long already. The second reason is you have to treat every pump as an individual. Depending on what it's been used for, how old it is and so on, the techniques you use for cleaning and the materials you use for cleaning will vary. So if I showed you the whole cleaning process on this pump, you might have another Leybold D16B. None of it would be appropriate for what you're doing. So you've got to kind of figure that out. But there is, as I say, a video that you can go and find on this channel that will give you the basic tips and ideas that we're working with when it comes to cleaning. And cleaning is absolutely critical. So we've got to install now the 2 shaft seals, which is done exactly the same way with the same driver set. In this particular pump, these two seals are identical. It uses the same seal in both positions. Most pumps will have a different seal for the outer and the inner, so beware of that. But for this one, it's quite straightforward. So again, it's a case of picking the driver that best fits the seal. Which looks like it's going to be that one. Grab the handle to go with it, and then to actually fit the seals, the easiest way is to, in terms of orientation, is to look at what you took out. But the actual theory behind it, if you want to know, is that the seals here, this is the inner seal and this is the outer seal, and the purpose of them is to maintain the oil from the oil pump between the two seals. So this is our outer face where the oil can't travel, and the oil will be coming up against this side of the seal. So they're both going to go what you might call face down, the easy way of installing them. So they can just be pushed in to start them, and again, you do want them to be as square and flat going in as possible. It makes it a lot easier. And then again, I'm just going to hit these with a hammer on the other bench. And then once they're driven in, just turn the part, make sure it looks like it's flat all the way around. That doesn't quite. Just going to give that another helping tap. Right, I'm happy with that now. Same for the inner. And that's the two shaft seals installed. So now we can set about putting the rest of the components together. Very important when rebuilding the pump that you have ample lubrication throughout. You do not want to assemble the pump dry, because when you first start it up, it's going to take a little bit of time to pump oil through all the passageways. If you start it up dry, you can actually have components damaged by running dry before the oil gets to them. So we're going to lubricate everything as we go along and make sure that doesn't happen. The order of assembling, everyone will have a slightly different idea, but essentially I've got the 5 core components there with the rotors and the vanes ready to go in. I cleaned up and prepared all the dowels, so they should hopefully slide in reasonably easily. And we'll work from the closed end, because it gives us a flat surface to put down on the bench if nothing else. So we need 2 of the short dowels. Just going to a small dab of oil onto them, and I'm installing these so that the threaded side is to the outside, so that I can access that the next time I take the pump apart. So those will go in like that, and if I give those a little tap, they're fairly tight, but hopefully just to get them so that they're standing proud, because they're going to guide as to where the components go together. On the stator here, one side I've got is flush with the gas ballast non-return. The other side has this orifice fitted to it, which I've cleaned. So that orifice is going to correspond with the hole here, so that those two sit together like that, and then I can drive those dowels in a little further. That's all solid. In fact, I can go ahead and drive those all the way through, or all the way in, till they're flush, which is where they need to be when we're finished. Going gently with everything, I don't want to mark anything up. And then the rotor can go into there. Now, the rotor looks different on either side. This side, which has the two pinholes, those are going to locate onto the dowels of the LabVac rotor, so they will come together like that. So that face obviously needs to be pointing up at this point. So this is going to drop into that hole there, into there, but we need to get the vanes in first. You won't be able to slide them in afterwards, I don't think. You might be able to get away with it. Anyway, we're going to put them in first. So a little bit of oil. There's no springs in this pump for the vanes. The vanes do not have springs. Then I'm going to oil the rotor itself, just to make sure everything is properly lubed up before it goes in. And then just let that drop in. And then make sure everything is happy, which it is. When you're doing that, turning the pump by hand, it's best practice, shall we say, to always turn it in the direction that it will be working when the pump's in motion and actually being driven. Most pumps, if you turn them in the opposite direction, it won't cause a problem. But there are a few out there that where you can get things binding up if you turn them in reverse. So best to just go the straight route. Next up, we have the what I call the centre bearing plate. It effectively acts as a bearing for the two rotors where they join together. So that will be installed onto here. But before we do that, we need to put the non-return in place. So we have this conical formed spring and a little pad. Just bring those together and make sure the spring's seated tightly on there. And that drops into the hole, which again can be tight, so just work it in and make sure it's gone all the way in and it's sitting reasonably flat. And then the bearing plate can go into place. Again, plenty of lube on there. Doesn't really matter whether you put it onto this side or this side. They're going to end up together. And that will sit onto there like that. And now we need the dowels. They're going to hold that together. Now, at this point we go for the longer dowels. These are going to go through that bearing plate. They're going to locate into the stator that's already there, and then we're going to locate the LabVac stator onto them as well. So my preference, and I believe it's the right way, I'm going to put the threads so that, as you saw when I disassembled the pump, you want to be able to access them from the outside if you like. So I'm going to fit them that way round in both cases, with just a little bit of oil to help them slide. One of which actually is sliding. The other one is, yeah, just about. They are very tight, and they're supposed to be very tight, obviously. Their purpose is not just to hold things together, but they actually perform the alignment of the pump. And then, once I've got them roughly in place, give those a little tap, leaving enough obviously for the next component to seat on. Then we can place the LabVac rotor, obviously aligning the 2 pins into there, and checking again that everything's smooth. That's good. Vanes in, and then just rotate it a little bit so that they're roughly out of the way for the next part, and then the rotor goes in. If at any point you get confused as to which way round, this obviously could install that way, could install that way, will only work one way. Check back to the inlet of the pump, always refer back. So on the end plate here, this is the inlet side, there is no port this side. So if the gases are coming in through there, they're coming into this side of the stator, which is giving us a large opening for gas to flow in, and then the small ports over here are the exhaust ports. So the large inlet and the small outlet will tell you which way around that should be. So I'm going to place that over all of that. And then just check, because obviously I didn't make any kind of measurement as to how much of those dowels is sticking out, so it will land on the dowels and be cocked one side or the other. But there we go. With a little bit of encouragement, on it goes. And then the end plate is going to go on next, but there's something that I'm going to do first, just to make my life a little bit easier. You remember when I dismantled it, I mentioned this very small key that the oil pump cog sits onto. That needs to go back in. Now I could install this, then fit it from behind, but it's a very tight fit if you do it like that. It's a very easy fit if you do it now. So I'm just going to push that home so it's there, and then you can install the final part. Now on here obviously I've got this shaft seal that I've just installed, and this is going to contact the shaft and end up sitting on this raised section. So I want to make sure that I go very carefully and don't catch that or nick it on that key that I've just installed, or do any damage to it on the way down. So that is in place. And then the final 2 dowels will go into here to make my alignment. And this time I'm going the other way round, because next time when the pump comes back for the next service, I want to be able to access the threads from this side, so they'll go in that way. And they're good and tight, they're not going to go easily down there. I can tap them into place, but they're going to end up flush in there, and what I don't want to do is damage the threads. It's unlikely, but I don't want to risk it, so I'm going to use a drift to just tap those down. So I'll get my drift on the edge, tap it in, it's not there yet. There we go, it's just starting to locate. I'll do it. I switch to a larger drift so I don't have to balance it on the edge. It just needs to go in deep enough that that covering disc will fit in, and then I'll equal it up on the other side. Go just a little bit deeper. And I can feel that they haven't come through. Parts going everywhere. This is where they'll be coming out. You can just see it's just coming proud there. So all my dowels are doing the job they need to do. They're all tight, they're not going to go anywhere. They may not be millimetre perfect as to their position, but they're doing what they're there to do. And that is the cartridge main components built. We can do all the auxiliary stuff next. The little disc that covers this dowel, I'm going to leave that until the last minute, because now that everything's clean and there's no oil on it to provide any kind of surface tension, I put that in now. It's guaranteed to fall out before the next component covers it up. So I'm going to leave that out for the moment. So the next thing to go in is going to be the oil pump components. My key is in place, so always fit the centre cog first. These will go in either way up, unless you've got any particular wear. So I'm just checking that part. This is in really good condition. If you've got a pump where the components are quite worn, then you need to kind of spot that as you dismantle and then put them back in the same way, because obviously the parts will wear together, and if you then assemble them the opposite way round to each other, they may not go back happily. So the centre cog locks onto that key. The outer cog you just rotate until it fits into the spacing. And there it is. And then we've got an O-ring to go in there. So back to my kit. And that's the skinny one. Fits there. So that's the oil pump in place, the O-ring in place. The next thing to go on is the outer plate, which carries the outer shaft seal, but also acts as the sealing face for the oil pump. Before I install that, we need to think about the rotor ring that goes in here. Now, I don't want to install this right now. If I install the rotor ring now, when I put the shaft seal on, it's going to be working against the lip. It's going to come up through there and be working against the lip of the seal, whereas if I put it in afterwards, it goes down through the seal. There's less chance of damage or any kind of misalignment. But what I do need to fit at this point is that little O-ring that seals the rotor ring onto the shaft and stops any oil leaks there. So I'm going to roll that onto the shaft and down, and it just tucks into its little groove there easily. So that's in place, ready for me. You do need to be careful. The keyway here has quite sharp edges. We don't want to damage that O-ring as it goes. Then the plate can go over, and as you'll see, there is no contact at all here between the shaft and the shaft seal at this point. So it goes on very easily. You haven't got to worry about damaging anything. Tighten those down. As with anything, any mechanical installation, it's best to get all the screws started before you tighten any of them down. If you tighten down in one position, one screw, and it's slightly out of alignment for the others, you'll never get the other ones in. So get them all started, tighten them down, and you'll see, although this tool you'll see is flexing and bending and it looks like I'm putting a huge amount of torque onto it, I'm really not. It's a 3mm Allen key. It cannot deliver any serious torque. So we're just nipping everything down. making sure they all feel equal. And that's in place, and then the ring can go in now. So it's going to be pushing down into that seal. So I just want to lubricate the front edge with a little bit of oil. The lubrication I'm using, if I haven't already said, is just the vacuum pump oil that it's going to run on. Nothing clever about it. So we give that just a light oil there. Slide it carefully down. Again, trying to keep it level so that it works its way down smoothly. And then just as it hits the seal here, I'm going to try and just rotate it as it goes to make sure it goes in smoothly. There we go. Just felt the seal give, so I can push that all the way down. So you see, it just sits proud of the seal. The seal is running roughly in the middle of that rotor ring at this point. Then the key can go back in, drops into the slot there, just give that a light tap. It's going to end up flush with the end of the shaft. Just bring it down to there, no further, and then the Rotex coupling can slide on. If you remember, this one came off easily, so it also went back on without any problems. Sometimes they're tight. If they're difficult to get off, it's a good idea to take a wired brush in a rotary drill, just run it up the centre of the coupling, just to clean everything up. That'll make it run on a little bit more smoothly. And then tighten that down. That one I'm going to give just a little bit more to. It's still a 3mm Allen key. It's not going to have a lot of force behind it, but that does need to just hold everything down to stop any leaks. So there we go. And then at that point, I just want to rotate it in the normal direction. Put it the right way up. Make sure everything's smooth. Okay. Don't want to feel any points where it's binding as it rotates or anything like that. We haven't got full compression onto all these stages yet until we bolt the thing in, but you should be able to feel that smooth, and you can just start to hear it making pumpy noises. Okay, so far so good. Still got a lot of bits left over though, haven't we? So the next things we've got going on, we've got the new valve plate going on. This is well divided up. It can only go one way round. There's a dowel pin here that it has to sit on. So it's completely pokey-okey. Can't go wrong with positioning on that. The backing plate sits on top of it. And then it just takes one screw to hold it down. Which I'll get started. And tighten down with a 4mm Allen key. 4mm Allen key, I should probably say. Stop these colloquialisms. That's the valves in place, and then while we've got it in this orientation, we'll fit the plunger that controls the shut-off. The way I do this, a very small seal, and it has to go into that very small hole in the top there. I use tweezers. There's probably other ways. I'm sure you can come up with something cunning and much easier to do than my method. So I've just used the tweezers to place the seal down into the hole, and then I can just about get one of my fat fingers down there to push it in. It doesn't take a lot. It doesn't need driving like the other seals we've seen. It will just push. It's very soft and it will push into position quite easily. So that goes in there. Then our spring, like I say, I've got two here. I cannot tell the difference. I would say that's the softer one and that's the harder one. I'm just going to throw one in. Never had a problem. If you know the exact tech spec of those, obviously one's for the 16, one's for the 25, but I can't tell them apart, even if I knew what the difference was going to be. If you do know, comment, call me out on it, because I'd love to learn. And then to hold that in place, we have again this little gasket. I just want to put that in by hand to make sure it fits. Like I say, sometimes they can be slightly oversized. You just need to trim very carefully around the beading. Then I should have, there it is, the disc that goes onto the top. Now this has got some witness marks. It really doesn't matter, it's a flat disc, but it does have a few witness marks on the outside that show where the circlip was holding it. So I'm going to keep it the same way up that it was before. Now the circlip, I hope you can see, this special circlip has these, what should we call them, eyes or lobes around it, and they're angled, they're actually bent in, so they point downwards, and they want to point down onto the assembly that they're holding. So there is a correct way up. It's one of the few parts, but that one does need to go in the correct way up so that it exerts the right force. This can be a little bit tricky. I'm going to take the circlip in the pliers. You want to try to avoid going all the way through, because the tips of your circlip pliers will prevent you from pushing it all the way down. So it's a little bit of a balancing act to make sure you've got enough to hold it, but without too much pointing beyond. And then make sure you've got spring, plunger, gasket and the retaining disc, and then take one little finger through the middle of the circlip to hold all that down, and then use the circlip pliers to squeeze it into place. It generally won't sit straight into the groove. There is a groove that snap ring now has to jump into. So I'm just going to gently tap at it until I see it pop into the groove, which it has done now. And then I'm going to work all the way round just making sure that it has truly gone home. You can see it, I don't know whether you can on the camera, but you certainly can when you come to do this yourself. You can clearly see when it jumps into the groove and opens out, taking up the space. So that's firmly in place. That will fall out if you run the pump with that circlip not correctly installed. It will pop out and the pump will cease to work. So a bit of care and attention on that one. And then the final things that need to go on here are the plate that goes onto the end here, which we can do once we've installed into the adapter, which is our next part to bring back. So here's my adapter, which I'm now going to lay down that way, and this whole thing will drop into place. And there's a gasket that goes in between two. This gasket does have to be the right way round. It's not difficult to figure it out, but it is quite easy to just throw it in the wrong way round. It will go in backwards and the pump won't work. So we can see we've got this shaped inlet port here, and we've got the corresponding shape on the gasket. And we need to turn that over. It needs to sit that way. This one is beaded only on one side. That's not always the case. So go by the shape. Don't just copy that the beading goes on one side, because that may not always be accurate. But it's fairly obvious now that our inlet port is working there. If I install it the other way up, no dice. So that's got it the right way round. And then our cartridge is going to drop into that. So this is the point where I do want to install that little disc that goes into the recess over there. Now, if I lift that up, it's going to fall straight out. So this can be tricky. First thing I'm going to try, sometimes works, sometimes doesn't. Just oil it and hope that the surface tension of the oil is going to hold it in place. So I'm going to have to lift this and lower it on. It's quite a heavy piece, but I need that to go in without that disc falling out. So what's it going to go on to? It's going to go on to the retaining rods. I guess you could put the cartridge onto the gasket, onto the adapter first, and then run the rods through. You might find it tricky to get the alignment doing it that way. Like I say, this is not a be-all and end-all definitive guide. It's just giving you a chance to see what I've learnt from my years of experience. And then that's got to come into there. Now, having put the rods in, that gasket is going to stay by and large where it should be. So this is how I like to approach it. Line up the rods and slide it along. It's pretty much how we took it apart, if you remember. It came off much the same way. And that way I'm not turning this upside down, so my disc is less likely to fall out on me. And at this point I can see that it's still in place. So it's a bit of a wriggle to get it in, but there it is. And at this point nothing can fall out, so I can tilt it back over, and there it is, the two are together. That's held in place with the 4 nuts. These are just a regular plain nut. Sometimes they can get quite khaki and then they're difficult to clean. So if you have got, just throw them away. Just put new ones in. It's not worth the aggro of trying to rebuild them. That washer was in the pot before I started, so I'm not going to be too concerned about that being a part left over. And then again, they just want to be tightened home. Now, how tight you do these nuts is fairly important. Can't give you a torque figure on it. I've never seen a torque figure for it. But if I turn the pump back round, then you can see that as I tighten those up, I'm actually compressing these stages together. So the more you tighten them, the less of a remaining gap you have between the stages. Now, I should be able to turn this freely, and you can hear now it sounds like a pump. Okay. If I don't tighten those up enough, and when the pump's running, my gases are going to escape between the stages. The pump will run, but the vacuum performance won't be very good. So you'll get something, but it won't be what you're expecting. If I over tighten everything, then the pump's going to bind up. So it's a little bit of a balancing act, particularly when you've got a pump that's maybe 20 years old. Everything's a bit worn. You take it apart, you put it back together again. If you did have a torque spec for these and you just went blindly on a torque spec, it might be too tight, might not be tight enough, it's not going to be accurate, that's the point. So you've got to go by how it sounds a bit, make sure it doesn't actually bind at any point. They're not wildly tight, I'm not using a big spanner, I'm not hanging on the end of it, but they are a lot tighter than anything else that I've done on here. So they need to be snugged up like that. You should have a good healthy pump sound like that, and that should be turning by hand smoothly, it's not binding at any point in the rotation, and I'm happy with that. When you run it, things might loosen up, you may need to go back in and retighten things. You shouldn't have to, but don't discount it. If you've got poor vacuum, it can often be on these just that the tension isn't quite right on there. So that's everything assembled on the cartridge, barring just putting the end plate and the cover over it. That's where we've got to. And it's looking pretty nice. So, final parts, I'm going to tip it up again just so it's easier for you to see. So this sits across here. These are our oil passages. The purpose of this is if you've got excess oil pressure within the pump, the pressure will come up through here. It will lift that flap and allow the oil to escape into the oil box. So it's a pressure regulator effectively. So that just sits in there. And we can wind the screws down to hold it. Just make sure it's sitting roughly in line with the curvature of the edge there, and it'll be in the right position. The accuracy doesn't have to be perfect, but you want it to be fairly central over that oil way. That's into place. It's getting heavy now. This is where our demister sits over. What that actually does is it traps a certain amount of oil and holds it over the valves. It stops you from having big clouds of oil pumping up, and it also keeps a little bit of oil over the valves. It just helps to keep them down and keep them sealed. So the clips sit in there, and then if you hold the retaining plate, just bend the clip backwards. So lift it backwards like that. So it clips on, and there we go. It's turning into a pump. So now we can drop that whole assembly into the oil box. The screws come in from this side, so it makes sense to lower it in that way. A lot of pumps, the screws fit the other way round, so you can lower the oil box onto the adapter. It's a little bit easier because the oil box weighs a lot less, but this is what we're given. This is what we've got to work with, and we need to seal that with the oil box gasket. Now the oil box gasket actually has a couple of holes for pins, and the pins are on here. So we've got one at the top and one at the bottom. Hopefully that's still vaguely in shot. And they will tell us which way round this needs to go. It will really only go one way, but if it lines up with those two pins, then it's correct. And then hopefully those pins will be enough to hold that gasket in place while we flip it over and lower it in. Watch your fingers at this point, because we've got a fair bit of weight going on here now. So you can grab it, because I've left this port open, I can use that as one point to grab it. Don't grab it from underneath. When it lines up, those pins have got to go into the pinholes here, and when they do, it will suddenly drop down, taking your fingers with it. So lower it in. Just give it a wriggle until those pins align. What I also, gives me a chance to show you what I missed on this occasion. The gas ballast control here on the outside, you want to line that up. You can see I've got it running vertically here, which makes it more difficult to get in. So you want to turn that so that it's horizontal. That's why the thing wouldn't sit down. Gasket's still in place. And there it goes. Once you get everything lined up, it drops together. And I didn't have my fingers in it that time, so that's good, isn't it? Still got all my fingers. Those 5 long bolts go through. Those need a 5mm Allen key. And again, just make sure that they all run home smoothly before you commit to any of them. And then if you go in a sort of crisscross pattern around them, everything will seat together and keep that gasket flat, which is what you need. Those can get just a little bit more. Okay, you don't need to go wild. These go into inserts in the aluminium. So what will happen is you'll start to pull the insert out of the aluminium if you overdo it. So caution, doesn't need to be super tight. Okay, now we're getting somewhere. So, inlet and exhaust ports. These have both been cleaned. These are absolutely identical. So at this point, have a look at them. Pick the cleanest one. Cleanest one becomes your inlet, regardless of whether it was before or not. Although it usually will be. Usually the exhaust is the dirty side. And then we've got 3 O-rings involved at this point. 2 go to the inlet side, 1 goes to the exhaust side. Now, I mentioned this when we took it apart. I don't grease these, because an O-ring shouldn't need grease, in my humble opinion. Push that into the groove, and that's not going to fall out anyway. But when you come to assemble it onto the pump, because it's on an angle here, I think that's the concern, is that that will tip off. So just bring it up to the pump like that, and then quickly snap it up. There's no chance that it can fall out while you're doing that. And then from my mixed up pot of screws, I know, because I've done this before, that the shortest ones are used for these. So, shortest of my remaining screws, machine screws, will go in there. Snug those home. The inlet has a few more components to it. First of all, we have a new pad. And like I say, when the pump is stopped, horrible noise. When the pump stops, this pad pops up against the underside of this, forming a seal and stopping any oil being sucked from the pump back into the apparatus. So those go together there. So the same O-ring goes into here as we had on the exhaust. With any O-rings, if you get one that does that, just slightly too small, gently give it a bit of a tug and it will give just enough. Obviously, the smaller the section of the O-ring, the more likelihood that you're going to rip it in two halves. So adjust your level of care and attention accordingly, and then the slightly larger of those O-rings goes onto the adapter. Then we need to take, there it is, the piston for the pad. One end of this has a little sort of mushroom head that pushes into the centre of the disc. It can feel quite tight, but be brave. It just pushes in like that, and then that drops down inside. I'm going to put the smallest of smears of oil on there, and then it pushes down into the centre there. It can really only go in one place. No spring on that, just drops in like that. Then the plate, so this plate, you can see this hole is offset. That hole lines up with the piston. Unfortunately, it looks like you can just about see what's going on. I can't tip the whole thing up, it's got too heavy for me. I'm an old man, I can't do it. Okay, so that drops in there. The inlet port sits over that, and I'm going to do it exactly the same way, even though that O-ring's not going to go anywhere. Snap it down on there, and then it might take a little wriggle to get those screws, because they're now going through the stainless plate and into the threads, so just a little wriggle to make sure they've gone in. Get those first two engaged with the threads, and I can dig out the remaining screws. Looser than I expected it to be. Again, the O-rings are doing the work. Don't need to put a lot of effort into this. Just snug them down. There we go. That essentially is the pump rebuilt. And at this stage, you can give it a turn for luck, and then we can go about fitting the motor. So a fresh new spider, I don't know what you call it where you are. Over here we call that a spider coupling. It looks vaguely a bit like a spider, I suppose. That goes in there. The motor drops in on top. So while you weren't looking, I did have to do a little bit of work on the motor. I just had to do a quick, very temporary rewire just to get it going because it turned up without a cable. And what I also did was remove the coupling, because another part that I haven't mentioned from my gasket kit is this ducting plate that I showed you earlier on. So this sits between the motor and the pump, which, if it's still all in shot, if I put it on this side, you can see it lines up such that you still have access to all of the screws, and the motor screws will come through here. So that goes in like that. It works the same the other way up. Doesn't make any difference. But again, the pins that locate it are actually on the motor side. So having worked out which way up it's going, I'm just going to flip it, put it on there, and line up the 4 pins. And that's where it sits. And the reason I took the coupling out is because the coupling sits in front of the ducting sheet. So you have to get the coupling out to do it. The coupling has a grub screw in there which lines up with the key in the motor shaft, and you access that with a long 3mm Allen key up from underneath. Okay, so that's going underneath the ducting sheet up to here. That allows me to undo the grub screw. This was very tight on, so the reason that it's leaving damp marks here is because I used a little drop of releasing compound. This is Plus Gas. Again, I don't know if you have Plus Gas where you're watching from. It's a fantastic product. It's kind of like WD-40, except it works. It's a proper releasing lubricant. So that's what I used. I just poured it, a little bit of it sprayed onto the top here, and left it for 10 minutes to work its way down and separate the coupling from the shaft to get that off. So I should have prepared this, but I didn't. Now, if you want to be sure that this is going to slide back on, like I mentioned just now, wire brush in a drill, run it up and down the centre here just to clean that up. Only takes a moment. Wipe it clean. Shouldn't need any more than that, but it will probably need to be driven down with a little bit of force. I doubt if it will slide on the way the other half of the coupling did. Line up the keyway with the key, hopefully. And then with a bit of a wriggle, it's at least got it started. It's going to need a little more encouragement, perhaps. Just using a seal driver like you saw me with earlier. A larger one than that. Just sitting in the middle. I don't want to whack on the plastic parts, obviously. I don't want to whack on the lobes here. I just want to take a driver that will be wide enough to sit between them and drive it down. Okay, that's moving fine. I'm happy with the way that's going on. If it was really tight and that wasn't moving, and if you had a motor No, I don't. If you've got a plastic cover on the end, as you're driving that, you're putting a lot of force down through onto the plastic fan cover. If you're really struggling to get this on, then it would be wise to remove that and then position something underneath so that you're driving down through onto the shaft of the motor and not plastic. Because again, if you crack it, you're going to have a bad day. So I've got as far as that. Mostly with motors, flush to the end of the shaft is great. That's where it's supposed to be. I happen to know with this, it's got to go in quite a bit deeper than that, and the shaft is going to protrude through. So I can't carry on driving it with that because it's hit up against it. So obviously various options there. One is to drive alternate sides around the shaft like that, which, because mine is fairly loose, has done the job. That's working fine. Again, if it's tight, put a socket on there so that the shaft can come up through the socket. I don't have one to hand that's the right size, but a larger socket than that will sit over the shaft and allow you to carry on driving it down. Or get a proper set of bearing drivers, which I've got over there but I haven't chosen to use. And I think that I still need to go a little bit further with that. This is something that if I'd thought about it in advance, I could have actually prepared, couldn't I, and worked out how far I was going to need to go back on, but of course I didn't do that. So then I can slide my Allen key back underneath there, nip up the grub screw, and then the moment of truth is whether this actually sets up nicely. I've set the coupling on the pump so that I've got the gap straight up the top, just so that I know that I need the coupling on the motor to be lined up the same way. Again, like I said earlier, watch your fingers, because this is going to go down with a bit of weight behind it. Lift it over. Sorry for the noise, the microphone fell off. And that sits in there. Now that is not sitting down properly. Okay, the good news is it was only the cardboard gasket that wasn't seated right, and not that coupling. I forgot to put the handle in. If you've forgotten to put your handle in at this stage, you're going to have to lift the motor off again. To do so, the handle slots in between the gasket and the motor, and then we go through the whole procedure of lining it up again. Always best to leave my failures in, because you might learn by them. And then I've got four screws, bolts, screws. Go in for that, and I've got a ball-ended Allen key to do those. Just makes the access a little bit easier, particularly around the terminal box. Up the top. Don't look at this and panic. That is what we call a temporary fix. Get some power into this thing just for testing. It's not how it goes out. The customer obviously removed The gland here that was carrying their cable, it must be a permanent installation that the pump's running from. So they've literally just disconnected it from the switch inside and pulled the gland and the cable out. So they've probably got that hanging out of a wall somewhere with bare ends, waiting for the pump to come back. Hopefully there's a master switch there. Okay, motor's on. Got 4 screws left, so there must be something else. And it's our lovely removable base plate. Base plate on these actually has a lug on here, so it will only go on one way round. Though it looks like it's pretty much symmetrical, so it will make a huge amount of difference. That's the final 4 screws going in there. Give it a wriggle, tighten it off. Pump's done. There it is, D16B all back together again. So this is now going to get some oil put into it, and it will go over to the test bench where it will run for a few hours and we'll get a final figure off it. If I remember, I will append that final figure to the video. One last thing to show you, all of the Leybold DB pumps have their fill plugs on an angle. I'm sure it's aesthetically pleasing to somebody. Back 40 years ago when they designed the pump, they thought, oh, we'll put that on an angle, that would look really nice. It's a right pain trying to get oil into them though, isn't it? Have you tried? So there's a couple of things you can do. You can tilt the whole pump up. It's fine with a D4B because it's little and you can just wedge something underneath and lift it up and get it a little bit more level. Truth be told, when you get up to these larger ones, get yourself a funnel that looks something like that. Preferably get a clean one. But, I think these are normally sold for putting ATF into car gearboxes or transmissions, depending on where you're watching. But this particular one is just the right size to sit there, and I can easily pour my oil into the pump. So that's the answer. Thanks for watching. Hopefully in a moment you'll see what the final figure was. Cheers. So there's our D16B all back together again, running nice, and hopefully the camera picks that up. 1/10⁻3, which is the limit of the gauge, so it's running really good. If you need any vacuum pump spares or any work doing in the UK, feel free to get in touch. If you've got any questions, leave a comment or contact me through the various details that are there on the site. Pleased to help. Cheers.